Okay, welcome to lesson 9.2, the second lesson in Unit 9, and we're going to continue our discussion about exponents and simplifying expressions with exponents. Today, we're going to focus on zero and negative exponents, two special cases we see when we have zero and negative exponents. So your aim in this lesson is that I can use rules of exponents to simplify expressions with zero and negative exponents. In math, people often invent ways to extend concepts to areas that might not make sense at first. Pretty much everyone can understand what 2 to the third means, because they understand it represents multiplying by the number 2 3 times. Yet, what does 2 to the 0 mean? Or 2 to the negative fourth? Does it make sense to talk about multiplying by a number a negative amount of times? Well, let's explore these ideas in the first exercise. So, exercise 1 has two different problems. It's got A and B. A is going to talk about the idea of 0. So letter A is going to talk about what happens when we have 0. So let's talk about that first. So letter A says, fill in the pattern for powers that are not negative. What does this lead you to fill in for 2 to the 0 power? So 2 to the 0 power is a very interesting case, right? What does that mean? How can something be multiplied 0 times? And wouldn't it just be 0? Well, let's follow this pattern and see what we discover. 2 to the fourth power is the same thing as saying 2 times 2 times 2 times 2. However, what's always that crazy invisible number that's in front of every number in math that we talk about? That 1. So it's also like saying we have 1 times 2 times 2 times 2 times 2, right? So 2 to the third would be 1 times 2 times 2 times 2, 3 times for the 2. And 2 to the second power would be 1 times 2 times 2. I forgot to put these as equals here. And 2 to the first power would be 1 times 2 to give you 2. So if we continue this pattern of 2 to the 0, it's really just 1. And do we have anything else? No, because we're not multiplying 2 at all. So it becomes 1. This leads us to this rule in this box here that says 0 exponents, b raised to the 0 power equals 1. In other words, anything raised to the power of 0 equals 1. Okay? Always. Anything to the 0 power equals 1. So a couple other little examples of this would be like if I said 3 to the 0, that equals 1. X to the 0 equals 1. A to the 0 equals 1. Anything to the 0 power equals 1. Okay, that's the first idea. And exercise A is an attempt to explain why it's 1, because it's kind of a weird thing. Okay? So then that brings us to the idea of negative exponents. So let's read at B. I'm going to use a different color. Let's use green. So let's read B. If positive exponents indicate multiplying the number 1 by 2 repeatedly, right? An exponent means you're going to multiply over and over and over that many times. The negative exponent should indicate, well, what's the opposite of multiplication? Division. Because what's the opposite of positive? Negative. The opposite of multiplying is dividing. So if we have something raised to a negative exponent, look, so that's a negative 1, we're really saying, well, we're going to take 2 and we're going to divide it that many times. So for 2 to the negative 1, we get 1 divided by 2. Because keep in mind, we always have that invisible 1, just like we had in the multiplying. So then 2 to the negative 2 would be 1 over 2 times 2. So to keep going with that pattern, 2 to the negative 3 would be 1 over 2 times 2, 3 times, which would give us 1 over 2 to the third, which would give us 1 over 8. This leads us to our second rule about negative exponents. Negative exponents, anything raised to a negative power is that same power as a denominator. So in other words, I can say that when you get something to a negative power, you flip it and make the power positive. Now, I believe these are two ideas you have learned in middle school, so these shouldn't be brand new concepts to you guys. Okay, now it's kind of a review here. So again, make a note where you are confused in this concept, please, and then ask me in class when you see me. because this is two very kind of confusing things, zero and negative exponents. Okay, so to sum up, anything raised to a zero power is 1 right here, and anything raised to a negative power, you flip it, put it as division, and make the power positive. So let's look at some examples of this as practice. So exercise 2. Oh wow, that came really big. Exercise 2. Which of the following is not equivalent to 5 to the negative 2? So 5 to the negative 2, let's write out how many different ways we can express that. So the first way I can represent this is, remember, this is a negative exponent. Negative exponent means I'm going to flip and make positive. So I'm going to flip it over, so I get 1 over 5 squared, right? Well, that matches number 1. So I know that it can't be number 1, because we're looking for what's not equivalent. So I've just discovered that that's equivalent. But I can simplify this again and say, well, this is 1 over 5 times 5. I don't see that in my answer choices, so I'm going to keep going. 5 times 5 is 25. Well, that eliminates answer choice number 3. And then if I hit Control plus Enter on my calculator, or type this into Google, 1 divided by 25, I'm going to get 0.04 as a decimal, so it can't be this either. The only one that it's not equivalent to is this 1 over 10. So when I put all of these equal signs here, I'm saying that really all 5 of these expressions are the same thing. They're equivalent. And when I say 5, I mean this one, this one, this one, this one, and this one. They all equal the same thing. I'm just writing them a little differently. Okay, that's equivalency. Alright, moving on to exercise number 3 for some more practice. Now let's talk about what happens when we have an equation with this kind of topic. So exercise 3 says, if f of x equals 3x raised to the negative 2 plus 2x raised to the 0 power, then which of the following is the value of f of 2? Show the work that leads to your answer, and remember that exponents always come before multiplication. So I know that I have taught you guys well that when you have f of something, this f of 2, you're going to plug in wherever you see an x, you're going to plug in the 2. Oops, sorry. So I'm going to take this and replace wherever I saw an x. See how there's an x here and an x here? I just replaced it with the negative 2. Okay? So now I'm going to simplify this. The 3 stays here, but because 2 is raised to the negative 2, I'm going to flip it. So I'm going to put it on the bottom and make that negative 2 a positive 2. So I've really just taken the 2 and I've put it on the bottom, flipped it, and made it positive. Right? This is my negative exponent rule. The next part, 2 times 2 to the 0 power, well, what is anything raised to the 0 power? It's 1, right? So this is like saying 2 times 1. That's my 0 rule. Sorry, my pen is being weird. That's my 0 rule. Okay, this looks a little bit easier to work with now that I've gotten rid of the negative exponent. Now this becomes 3 over, what's 2 times 2? 4. And then 2 times 1 is 2. Even easier, 3/4 plus 2 is 2 3/4. And does that match any of our answer choices? It does. It answers choice number 1. Okay. You could have also done it a different way, and I'll show you that other way as well, just to give you an idea. So this is the first way. Let me split my screen here with this pen. So here's my second way I'm going to show you in blue. So in blue, what I could do is I could say, okay, look, I know f of x equals this confusing looking equation, 3x to the negative 2 plus 2x to the 0. Why don't I rewrite this confusing equation to something easier? I'm still going to use my rule, but instead I'm going to keep the variable. So the x goes on bottom, and this x to the 0 power cancels out to a 1, so it's like saying 2. Now I could just plug in the 2 in for the x that's left, and this possibly might have been a little bit easier for some people. Either way works just fine. You still get the 2 and the 3/4 at the end. Whichever way that you prefer to do it. Either simplifying it before and then plugging in, or plugging in from the very beginning and working your way down. Okay? All right, let's turn the page. Okay? And let's combine this with our other laws we learned, well, we reviewed in lesson 9.1, where we multiply exponents and we raise exponents. So here are two other rules that we've learned. The first one is that, when you multiply terms with exponents, you really add. And our second rule is that when you raise something to a power, you multiply exponents, right? You distribute that b to the a and get a times b. So that's what we kind of practiced in 9.1. So now let's see if we can develop another rule for dividing quantities that have the same base. I briefly talked about this in 9.1. So for letter A, let's do it both ways. The first way was the 9.1 way, where I take out what they have in common. They both have an x squared, and I'm left with what they have over. This cancels out to 1. I'm left with an x to the third. However, notice that this is the same thing as saying x to the fifth times x squared is the same as saying, that this is the same as saying x to the 5 minus 2 to give me x to the 3, because I have a 5 and a 2 here. Okay? So this concept, it appears that x to the a divided by x to the b is really x to the a minus b. So we can sum up and say, when you divide terms with exponents, you subtract the exponents. And we talked about this briefly in lesson 9.1. So let's come back to letter B. If I have 3 to the 10 over 3 to the 5, it's like saying 3 to the 10 minus 5 to give me 3 to the 5th. And letter C, here I have x to the 8th over x to the 2. It's the same as saying x to the 8th minus 2 to give me x to the 6th. So it's a shortcut, right? We don't have to do the work I did in red, where I pulled out the x squared, crossed it out, right what's left over. I can kind of skip that, and this is like a little shortcut right here. Okay, this is a shortcut. It will save us time. Okay. So let's combine some of this stuff here and take a look at exercise number 5. Now we have a pattern that works well if the exponent is greater than that of the denominator. But does that same thing work if it's not? So what this is saying is, you see how in all three of these examples the numerator is greater than the denominator? 10 bigger than 5, 10. So here 10 is bigger than 5. Here 8 is bigger than 2. What happens if that's not the case? So let's look at letter A here, or I have 2 to the 4th divided by 2 to the 4th. This problem wants me to do it both ways. The long way, by using the techniques we used in 9.1, and the shortcut way. So I'm going to do the long way. Actually, I'm going to do the shortcut way first, and I'll do the long way. So the shortcut way is saying, look, this is the same thing as 2 to the 4 minus 4. I'm subtracting, because this is division, and I end up getting 2 to the 0, and I know anything raised to the 0 power is going to be 1. So 2 to the 4 divided by 2 to the 4 is 1. The long way to kind of think about this, or not using the shortcut, is to say, hey, look, anything divided by itself is 1. Right? And we know this. An example of this is like saying 3 divided by 3 equals 1. X divided by x equals 1. So why wouldn't 2 to the 4th divided by 2 to the 4th equal 1? Same idea. Okay? Alright, letter B. We'll do the shortcut first. X squared divided by x to the 7. Well, since I'm dividing, I'm going to subtract these exponents, so I get x to the 2 minus 7. This becomes x to the negative 5. I can't have negative exponents, so what's my rule say to do? It says to flip it and make that exponent positive. So I get 1 over x to the 5th. The long way to do this is to say, okay, let's take out an x squared over an x squared. What's left on top is a 1, and what's left on the bottom is the x to the 5th. I still get 1 over the x to the 5th, but it's a bit more of a conceptual change. I'm not just using a shortcut where I remember to subtract. Okay? And finally, take a look at the last one for some more practice. You could pause and try this on your own if you like as well. You always can do that. This becomes 5. I'm dividing, so it's 6 minus 10. 6 minus 10 is negative 4, so it becomes 5 to the negative 4th. I can't have negative exponents, so this is going to be 1 over 5 to the 4th. Okay? The long way is where I take out what I know they have in common. They each have a 5 to the 6th in common, so that cancels out to the 1. A 1 is left on top, and a 5 to the 4th is left on the bottom. I still get that 1 over 5 to the 4th, but conceptually, again, a little bit trickier. Okay? So, to sum up, we've talked about powers raised to 0 is going to be 1. If you raise them to a negative power, you have to flip it. We've talked about when you divide exponents, you really subtract them. And when you multiply exponents, you're really adding them. So let's take a final look at exercise 6, which will lead us into 9.3, and that's talking about exponential functions. So now that we see the subtraction for exponents is consistent with negative and 0 exponents, for now we want to be comfortable that negative exponents indicate division and positive exponents indicate multiplication. That's a big takeaway from this lesson. So exercise 6, consider this function. F of x equals 16 to the 2x. Now this looks weird because look at where the variable is. The variable is the exponent. We haven't worked with these yet this year, so this should be very new to us. It might be something you saw in middle school, but as far as my classes are concerned, this is a new concept where x becomes the exponent. So we're going to not use our calculator and try and use our rules to simplify this problem. So, letter A says f of 0. Well, f of 0 would equal 16 parentheses 2, but now instead of x, what am I going to replace it with? Hold on. My pen is being uncooperative. 16 parentheses 2, and what am I going to replace x with? A 0. I'm replacing the exponent now. Now I can simplify this. F of 0 equals, keep the 16, but what's 2 raised to 0 power? It's 1. So it's like saying 16 times 1, and so then f of 0 is just going to be 16. Okay? Letter B, a little bit trickier. F of 2. Now I'm going to plug in 2. I'm going to leave the 16 in the parentheses 2, but now instead of x, I'm going to make the exponent a 2. Now we simplify. I keep the 16, and 2 to the 2nd power is 2 times 2. Which gives me 4, and 16 times 4 is 64. Okay? And finally, a negative x. This is going to equal 16 parentheses 2 raised to the negative 2. So let's be very careful here. Again, leave the 16. It's not being affected by the exponent at all. And this right here, this 2 to the negative 2, becomes 1 over 2 to the 2 because it's a negative exponent. I flip it and make the 2 positive. When I do that, I end up getting 16 over 2 times 2. And this becomes 16 over 4, and so I get a final answer of 4. So it's really important to have these rules memorized, that we're careful and don't make a lot of mistakes. Because you'll see in lesson 9.3 and 4, which are combined, that we're going to work a lot with exponential functions, and we've got to be really good at these skills and these practice problems. So take the fluency really seriously. Don't copy the answer key because it's really going to test your efficiency at being good at exponents. Okay? Please ask me questions in class if you need it, and good luck on your fluency.